Hi, this is Mr. Ward, and I'm going to talk about Chapter 5.3, number 23. And we've got this trapezoid here. And I know it's a trapezoid because it has exactly one pair of parallel sides. So we have been given circle O, and we know that line DC is parallel to line AB. So we know this is true. We know those are parallel. And we're supposed to prove that AD is congruent to BC. So I'm going to put a little question mark here and a question mark here. Okay, it would probably be useful for us to draw a triangle. Well, it's really neat that this is a circle centered at O because every radius of this circle is going to be congruent. So I'm just going to identify those congruent radii. How cool is that? So I've got some congruent radii. Now, because I've just made triangles I've made 3 triangles and they all have 2 pairs of congruent sides. Well, that's going to lead us to this. This angle is congruent to this angle, is congruent to this angle, is congruent to this angle, is congruent to this angle. Well, let me back up for a second. I'm going to actually clarify something. So let's just start with these 2 angles. These 2 angles are going to be congruent because that's an isosceles triangle in the base there. Now, this is a transversal here. This line, I'm going to make that green line longer so it's really clear that's a transversal. That's a transversal right there, which means I've got an alternate interior angle situation here, and I've got an alternate interior angle situation here as well. Okay, so what I can now say is this angle is congruent to this angle, which is congruent to this angle, which is congruent to this angle as well. Okay, so now I've got these angles are congruent. At this point, I have everything I need. It is also true that these 2 angles are congruent to each other, and these 2 angles are congruent to each other. They are not congruent, as I was starting to imply earlier, to these angles. I got a little ahead of myself, but because these are isosceles, it is true that these angles are congruent. However, that's not the key to this. The key to this is that I've got this side, and this angle are congruent to this side, and their included angle as well. So I can now prove that triangle AOD is congruent to triangle BOC by side angle side. So side angle side gives me these 2 triangles are congruent. And then you just have to work with Kappa-Kadika at that point. So the key trick to this one is that radii are going to be congruent for the same circle. And these 2 radii make this triangle at the bottom an isosceles triangle. And therefore, these radii are, of course, part of a transversal here and a transversal here. And so we have alternate interior angles, and that leads us to side angle side, side angle side, and Kappa-Kadika for the win for the last part. I'll let you finish it up. I hope